This is Mr. Ashton going through the mathematics higher tier non-calculator paper from the summer of 2017. In terms of the first 10 questions, I've already done those in the intermediate paper, so there's a link below if you want to go and have a look at those. It'll be the last 10 questions in the intermediate paper. Okay then, so the first question that we had higher was as follows. It says, evaluate 49 to the power of minus a half. Now, you should know that anything to the power of a fraction is the denominator is that root. So a 2 would be a square root, a 3 would be a cube root, a 4 would be a fourth root, and so on. So it has to be the square root of 49. It would then be to the power of the numerator, so effectively to the power of 1, but everything's the power of number 1. It's just a normal number, so there's no need to go and add anything extra onto that bit. But it's this bit here that you're expected to know. This is the crucial bit here. The minus means 1 over. That's what that bit means, okay? So it means 1 over the square root of 49. So in terms of what that would actually be, that would be 1 over 7. For part B, it says express 0.372 with recurring dots on the 7 and the 2. The way that I always complete these, I've done quite a few of these in recent videos, is that I state for the angle, I state for the decimal to be as a letter, if I can get my words out, but I take out the reoccurringness of it by actually writing those numbers, okay? Now notice I've left space above it, and the reason why I've done that is because I'm going to times this decimal by, in terms of having 2 reoccurring dots, times by 100. If it was just 1 reoccurring dot, it'd be times by 10. If it's 3, it'd be times by 1,000. So by timesing this by 100, I would get x times 100, which is 100x, and then timesing this by 100 would shift everything along 2 places. And so on, okay? So from there, I subtract these two decimals. So that is going to equal, and notice I've lined up the equal signs and the decimal point. They're going to cancel, loads of cancelling going on here until we get to here. 2 take away 3, we obviously can't do, that would be minus 1. So we borrow 1 or steal 1 from here, that becomes 12 take away 3 to get 9. And then 6 take away nothing, and 3 take away nothing to get 36.9. But what's equal to 36.9 is 99x. 100x take away x is 99x. Then you would effectively get 36.9 divided by 99, but there's a big issue here. You cannot have a decimal in a fraction. So what I'm going to do to remove that decimal is times it both by 10 on the top and the bottom to remove that decimal, okay, to get 369 over 990. It doesn't ask it for in simplest form, so there's no need to cancel that down. The next question, there's an easy way and a hard way to do these. The hard way for me would be doing FOIL by expanding out that, by saying squared means times by itself, and then expanding and then solving it that way. You can do that, that's still correct, but there's an easier way to do this. So I'm just going to write out my square numbers, so 1 times 1, 2 times 2, and so on, up until I get to at least 63, but no point going much further than 63, okay? So where are we here? 36, 49, and then 64. Okay, we want to see if there's a square number that goes into 63. I know there's no square number that goes into 7, it's a prime number, but if we have a look, we know that 64 can't go into 63, 49 doesn't, 36 doesn't, 25 doesn't, nor does 16, but 9 does. 9 goes into 63. So I'm going to rewrite this as the square root of the 9, the square number, times by 7, and then I want to take away root 7 and then square that. 9 root 7 would be the same as, square root of 9 times 7 would be the same as 3 root 7, take away root 7, squared, and then 3 root 7 take away root 7 would be 2 root 7. It's a little bit like saying 3x take away x would be 2x. Squared means times by itself, so I'm going to now do 2 root 7 times by 2 root 7. The 2's will times each other to get 2 times 2 to get 4, or 2 squared is 4. And then root 7 times root 7 is 7, so it's just 4 times 7, which is 28. Okay, then the next question. Now it says A, B, and C are points on the circumference of a circle. So I tend to call this a cyclic triangle. And if I've got a cyclic triangle, I know I'm looking for one of my circle theorems in particular, which is called the alternate segment theorem. Okay. Now, It says BAY is 74 and ABC is 53 degrees. Prove that triangle ABC is the cyclic triangle because all its vertices are on a circle, is an isosceles triangle. Now, the alternate segment theorem tells you that this angle that is generated here, this 74, will be the same in the opposite corner up here. Okay, so I know what that angle is. I just need to state what it is in my working down here. Okay, so this angle is from B to C to A because they've asked me to give a reason for any statement. So I'm going to say BCA is equal to 74 degrees because of alternate segment theorem. That's all I have to state to get 2 marks. Okay, now all interior angles of a triangle add to, we all know this, 180 degrees. So 74 add 53 gives me 127. 180 take away the 127 gives me 53 degrees. So I'm going to point to that and say missing angle is 53 degrees. So that's that angle there. Then I've got 2 angles that are the same, so I must have an isosceles triangle, okay? The other one is different, so I'm going to say as 2 angles are the same, we have an isosceles triangle. Okay? Okay, the next question is one about shading regions. So get a pencil and a ruler ready. I will start going through the question in about 5 seconds. Okay, so the first one says x plus y is less than or equal to 6. Now, in terms of what you do for this, okay, totally ignore that inequality sign to begin with. And just treat it as an equals. The same with all of these, okay? You just totally ignore the inequality sign to begin with. Okay? Now, there's 2 graphs there that are super easy to draw. X equals minus 2 is the easiest because you do what it says on the tin. X equals minus 2 is a line that goes straight through minus 2. It's parallel to the y-axis, which is why some people get it confused and do it the wrong way. But if you look at the value of x every time, it's always minus 2 every time on that line above and below. Okay, so we've got that one done there. Now this is rare that it comes up this nicely, but this just says give me a number plus another number to equal 6. Okay, 6 add 0, 6, 0 add 6, 6, 3 add 3, 6, 4 add 2. Any of those set of coordinates will work. Basically, if it's just x plus y, and equal to a number, you can put your ruler through both of those values, so 6 and 6, and draw a straight line through them. Okay? Now, this is the final one that we haven't drawn that I do need to do. So to do this one, I need to do an xy table. So I'm going to say x and write out my formula. So y is equal to x over 2 plus 3. And when I choose my values for x, I normally choose 1, 2, and 3. But because I'm dividing by 2, I'm going to be quite smart on what numbers I choose. I'm actually going to start off with 0. 0 divided by 2 is 0. And then add 3 would be 3. And then I'm going to go up in even number. Even number divided by 2 will still be a whole number. So 2 divided by 2 is 1. 1 add 3 is 4. And then I'm going to go 4 as my next even number. 4 divided by 2 is 2. Add 3 is 5. Okay, so now I'm going to plot 0, 3, 2, 4, 4, 5. So 0, 3, 2, 4. So it's actually on that line already. And 4, 5 there. Check my ruler goes through all 3. If it doesn't, I've either substituted in or plotted incorrectly. But we're fine. Okay, now it comes to a place where we need to start worrying about those inequality signs. This one here said x is greater than or equal to minus 2. So greater than or equal to minus 2, the values of x that are greater than or equal to minus 2 is everything to the right of this line. So effectively, I don't want anything on this side of the line. Okay, I'm shading the side that I don't want. Okay, now the problem is with these two here, it's not that obvious of which side we're going to go. So I'm going to choose an area that falls out of both of them. And I love this area if I can find it, which is the origin 0, 0. I'm going to plot 0, 0. I'm going to substitute 0, 0 into here, okay? So I'm going to get 0 is greater than or equal to, so you can see what I'm doing here. 0 is greater than or equal to 0 divided by 2, so that is 0, plus 3. Is 0 greater than or equal to 3? No, that's false. So for this line, which I just drew for that, I don't want this side, so it means I want everything above this line. So I don't want anything this side of the line where 0, 0 was. Okay, now using 0, 0 again, I'm going to sub it into here. So I'm going to say 0 plus 0 is less than or equal to 6. 0 plus 0 is 0. Is 0 less than or equal to 6? Yes, it is. So for this line that I drew, it went through the two sixes, it actually is the right side of the line. I want it this side of the line, so I don't want anything this side of the line. So by shading the area I wasn't interested in, I've actually been left with a region that's nice and obvious to which is the bit I wanted. But what I always do to make it really stand out is R. Okay, R for region. I think that's really nice and obvious to clearly indicate the region that is represented by my answer. I'm going to just put equals R there as well. Okay, now if in doubt, the triangle drew, it will be that. Okay, if it's 4 lines, it will be a 4-sided shape. You just have to try and look for it and hedge your bets to what it is. Okay, but as long as you can draw these graphs, you'll pick up 2 of those 3 marks anyway. Okay, then over the page to 15R, it says, what is the greatest possible of x where all the conditions are met? So what is the biggest value on my x-axis until the region stops? Is this value here. Okay. We were also asked, well, what's the greatest value of y, which is this value here. So the greatest value of y is the highest one, that's 8, and the greatest value of x is 2. Okay. So 2 for x, 8 for y. Okay, and over the page on 16, it says about all the different conditions for congruency. Now, first of all, I can tell you straight away that these are not congruent because although all the angles are the same, that is not a condition for congruency. Okay. Now, what I'm going to say is they're definitely not congruent. Well, that's not true. They could be, providing these are all exactly the same length, but they're not drawn to scale for starters. Okay. But they're not necessarily congruent. Although all the angles are the same, all the sides have to be the same as well. We're not told that, so I'm going to say not necessarily congruent. They're definitely not congruent. We can't say that. And they're definitely not congruent because we're not told any of the sides at all. So they're not necessarily congruent. The next one here stems off that we're given a side with 2 included angles. Okay. Now, I know from the 7.8, the 2 angles that must come off it are 56 and 64. If I look at the 7.8 here, I'm only told one of those angles there, and one of those angles is 60. Now, if you work this one out, you think, oh, well, okay, they are congruent, but they're not because they've got to be 64 and 56 coming off the 7.8. So it's regardless if that's 56, they're both the same there. Those 2 aren't. So because those 2 are different, these are definitely not congruent. Okay. And then if you look for this one here, we've got 64 in between a 7.2 and a 7.8. Okay. Now, if I look at the 7.2 and the 7.8 there, yes, and 64 is in the middle. These are definitely congruent. And the condition is side, it should say included angle. That's what you'd be expected to write. And then a side, okay? So the side, and in between them, we're given the same angle both times. Okay, over the page, it says, using a sketch of the graph of sine y equals sine x from 0 to 360, you must label important axes on both axes. You must label both important values on both axes. Okay, you're expected to know that the value or the sketch of sine is a wave that looks something like this, and you need to know where it starts. It starts at the origin. Okay, it will then do a wave like that, and it will repeat underneath. Okay, now it will rise and fall by a value of -1 and 1. Okay, so it will rise by 1, come back down to 0, down to -1, which is supposed to be that value there. What I'm going to do is just make it really obvious, because my line, oh yeah, that's a really bad drawing. I haven't got a rubber, so I need to just draw that faintly, and then obviously if I had a rubber, I'd go and rub this bit out, but I'll just scribble out to show that it's not being used. This happens, it rises and falls every 90 degrees. So 90 will go at 1, this would then be 180. It would then drop to -1 at 270, and then it would start its journey back up again. So this would be 360. At 450, which would be a further 90 on, it would be back up to 1, and so on. Okay? Now, we're then asked to circle the value that is equal to sine of 200. So look where 200 is on your axes. It's here, roughly by the 180. So that value there, where else on that graph is it equal to that value? Okay, so if I draw a line across there, I can see that it's up by here. It's in between 270 and 360, quite close to 360. That's not in between 270 and 360, so it's not that, not that, that. It must be that. Okay, that's in between there. And you notice there, 200, between 200 and 80 is 20. In between 360 and this number here must also be 20, so that would be 340. Okay, then question 18, it says the diagram shows two rectangles. By the combined area of both the rectangles is 50 centimeters squared. By considering the area of the two rectangles, show that 2x squared minus 5x minus 25 is equal to 0, and hence find the value of x. Okay, now we're told about the areas of this. So it says the areas of the triangle. So they obviously want me to work out the area, which just is very easy because I can just do base times height there, or length times width. But this one here, if I look at the width, it's x minus 3, but I don't actually know what this long line here is. They haven't told me what it is. However, I do know that this bit here is 2x, and I know what this bit is here is x. So this whole length here must be 3x. Okay, I'm going to call this A and this B. I'm going to say that A plus B, the two areas, is equal to 50 centimeters squared. Okay, to work out area A, I need to do 3x times by x minus 3. To work out B, I need to do x times by x minus 1, and that is equal to 50. I'm going to expand these brackets out now by multiplying both bits, both similar brackets. So 3x times x would be 3x squared, minus 9x plus x squared minus x is equal to 50. Okay, now you see that they have this equal to nothing. That means they brought the 50 over to the other side. So I'm going to do that and simplify what I have on this side. So I've got 3x squared. The other x squared I have is a plus x squared. So I'm going to have 4x squared, and then I'm going to have minus 9x, and then take away a further x to get minus 10x. And then the plus 50 will become minus 50 on this side, is equal to nothing. Now the issue is they said show that it's this, and I have this. However, you'll notice that everything is even. So what I can do is I can halve both sides. Now this side is easy in particular because nothing divided by 2 is still nothing. And then half of each of these becomes 2x squared minus 5x minus 25. And that is what they wanted. So I know I've done the correct thing. The next thing I need to do is to factorize that. So what I'm going to do is times together the first and the last term to get minus 50. 2 times minus 25 is minus 50. And my numbers must also add up to whatever's in the middle, which is minus 5. I am now looking for a pair of numbers that times together to give me minus 50 and add up to negative 5. Now, if they times to minus 50, we must have one of each sign. If I have two negatives times together, they'll give me a positive. If I have two positives times together, they'll give me a positive. So the only way that can be a minus is by having one of each sign. Two numbers that times together to give me 50 are 10 and 5. Plus 10 take away 5 will give me plus 5. I'm supposed to have negative 5, so that's not my combination. But all I'm going to do now is switch my combination to be plus 5 take away 10. That would give me minus 5. That's my combination. Now, the way that I factorise might be slightly differently to the way you factorise. The way I factorise is I look at the expression that I'm factorising, or the equation in this case, and I drop just the squared term here. So I drop literally just the squared, and in the front of two brackets I write 2x and 2x from here. In one bracket is going plus 5. In the other bracket is going minus 10. And because this is equal to nothing, I still need to put this equal to nothing. Now, if you use this method, what you must do is you must cancel down any brackets that you can. 2x and 5, there's not a number that goes into 2x and 5, so it stays the same. This is even, and this is even, so I can halve each of those. And you just halve it. That's all you do to do this method. Okay? Then, if I expanded this out, 2x times x will give me 2x squared. 2x times, plus 5 times minus 5 will give me minus 25. And the rest of it will work out as well. Finally, to solve this equation, if we change the plus 5 over to the other side would be minus 5 by 2. So x is either minus 5 over 2 or x is 5. Now, x clearly can't be a negative number because it's all relating to areas. So it's not that answer there. This would be my answer. Okay? Okay, we're on to one of the last questions now. So it's obviously not going to be a particularly easy question, and they do put in bold here that this is without replacement. So this is what we call conditional probability. It tells you that I have 6 red blocks, 4 green blocks, 2 yellow blocks. So 12 blocks in total. Okay. What is the probability that the first block removed is red, then the second is green, then the third is yellow? So they give me a very specific list to go through. So the first one is red, then I get a green, and then I get a yellow. Okay. Now, the way I'm going to work that out is by saying to get a red, I'd have 6 out of 12. Multiplies by, then I get a green. So we have 4 greens, but there's been 1 taken out and not replaced. So 4 out of 11. And then I'm going to times that by 2 out of 10. Okay. Now, that's obviously very hard to do off the top of your head. You haven't got a calculator, so you can't use that to help you. So what I'm going to do is just do some cancelling down of fractions across the lot. Okay. Now, first of all, I'm going to divide top and bottom of this fraction by 2. But when I'm timesing, it doesn't actually matter where I do it because it's all equivalent to one big fraction. Okay. So now I'm going to divide top and bottom by 2 again to get 1 and 1 there. I'm also going to divide by 2 again to get 2 and 5 there. Okay. So what I can do now to answer this is do 1 times 2 times 1, which is 2. And then I've got 1 times 11 times 5, which is 55. So the probability of that happening is 2 out of 55. The next question says calculate the probability that all 3 blocks are the same colour. Okay, so the probability of getting all the same colour, I can either get probability of red, red, then a red. I'll work that out in a second. The other ones I could get is a probability that I get a green, green, and a green. Or I could get the probability of getting yellow, yellow, and, oh, hold on, I can't, because there's only 2 yellows in there, so I can't do that one. It's one that I can't do. Okay? Probability of getting red, then red, then red would be 6 out of 12 times by 5 out of 11 times by 4 out of 10. Okay? Again, I can't answer that easily, so I'm going to do that same trick again. I'll cancel that down to a half. I'm now going to divide top and bottom by 2, so that becomes 2 and that becomes 1. I'm now going to divide 2 to get 1 and 5, and I'm now going to divide by 5 to literally get 1 times 1 times 1 to get 1. 1 times 11 times 1, which is 11. I'm now going to do the same for green, which is going to be 4 out of 12 times 3 out of 11 times 2 out of 10. Use the same method as I just did. Divide both by 4 to get 1/3. Divide by 3s to get 1. And then divide by 2s to get 5 there. So the tops will give me 1 times 1 times 1, which is 1. And then 1 times 11 times 5, which is 55. So then to work out the probability that they're the same colour, so P same colour would be 1 out of 11 plus 1 out of 55. Problem is those denominators aren't the same, so I'm going to change that to being 55 by timesing top and bottom by 5, which will give me 6 out of 55. It then says write down the probability that the 3 blocks will not be the same colour. So P will literally just be 1 take away what we worked out. So 1 take away 6 out of 55 would be 49 out of 55. Okay, then the next question is one on the trapezium rule. It tells us that this graph is y equals x squared, although we can read the values off the graph. It then says use the ordinates 0, 1, 2, 3, 4, 5, and 6 to estimate the area of the region shown. Now, the first thing I'm going to do is draw lines up from the ordinates. Now, 0 is already there, but 1 to that one there, 2, 3, 4, 5, and 6 is already drawn for me. Now, in here, that is area A. Now, it's tiny area A. Area B is in here, area C, area D, area E, area S. So they get bigger and bigger and bigger. But what I need to do is know what the values are of each of these. So this is 1, so 1 squared would be 1, 2 squared would be 4. You can read them off if you want instead. 3 squared would be 9, 16, 25, and 36. Okay? I'm now going to go and work out the area of each of those. Now, A, because I'm just estimating this because it's a curve, A isn't actually a trapezium, it's just a triangle, and it's going to be a half of base times height. So it's going to be a half of the base being 1, the height being 1. Okay, that is 0.5. For B, it's going to be half of the parallel sides. So this side here, 1 plus 4. So it goes from 1 to 2. So we're going to add together 1 add 4, which is 5. Half of 5 is 2.5 times by 1 is still 2.5. That times by 1 is going to be the same every single time. So it'll make absolutely no effect to our answers. So let me just go and start setting up the rest of the question here. Now this one here for C, we already know that last number there, 4, they're shared between B and C. So it'll be a half of 4 plus 9. 4 plus 9 is 13, half of 13 is 6.5. Then it's going to be a half of 9. What we finish on there will start off here, 9 plus 16. 9 plus 16 is 25, half of that is 12.5. Then it's going to be a half of 16 plus 16, 25. 16 plus 25 is 41, half of that is 20.5. Then half of 25 plus 36. 25 plus 36 is 61. 61 halved is 30.5. Okay, now rather than just diverting to like our old school method of just adding everything together in column form, let's just see if we can make things a little bit easier for ourselves here. Notice here you've got 2 and 6 make 8 and 12 is a number bond, so that's 20. Add another 20 is 40. Add 30 is 70. So we've got 70 plus 6 lots of a half, so 6 times by 0.5, that's 3. So the answer is 73 area. Okay, finally we are on to the last question. Now it says, by considering algebraic expressions show that it is never possible for the surface area of a sphere with radius r to be equal to the surface area of a cube with sides r. So the first thing I'd recommend is drawing out what that could look like to help get your head around it. Here is a cube with sides r. I don't know how long they are, but they are all the same, and it is a cube. They're all the side of r. A square here, this square here, this square here, 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 and underneath. There's 6 of them in total, and they'll all be the same. So it's a cube would be 6 times by r times r, so 6 times r squared, which would be 6r squared, the surface area for the cube. Okay. Now, in terms of the surface area of the sphere, if you go and look at your front page, your formula sheet, it tells you what the surface area of the sphere is. Okay, so surface area sphere is equal to, oh, and look at that, they've actually used r as well. Okay, so that's equal to 4 pi r squared. It says it right there. Okay, now in terms of that, we've now got an expression for the surface area of the cube and for the surface area of the sphere. That r is the same as the length of the radius of their sphere. We're then asked to say, by considering algebraic expressions, show that it will never be possible for the surface area of the sphere will be equal to the surface area of the cube. So basically, we want to show that 6r squared is not equal to 4 pi r squared. Okay. Now, at the moment, there could be a value where they both work, but as r squared is in both, I'm going to divide both sides by r squared, so they cancel out, and then we get 6. 6 is equal to 4 pi. Well, 4 pi is like to 2 decimal places. It even says again on the front sheet somewhere. Probably won't be able to find the front sheet easily, though. No, can't. Somewhere in here. Well, on the front it does say, and you should know this, that pi can be thought of as 3.14. So 4 times by 3.14 is obviously not the same as 6. So that's me proving it, okay? That's the end of the paper. Hopefully you found that useful. If you did, please hit the subscribe button and you will have access to any more papers as and when I release them. Thanks for watching.